Hey class, welcome to the Chapter 4 review packet. So let's run through a whole bunch of examples today that will help prepare you for your test whenever you decide to take your test. So hopefully it'll be tomorrow. Anyway, getting to this. So your test will be very much like the review, just probably not as many problems. So on the first one, it says, write the following equations in function notation. So when we're talking function notation, basically remember that f of x is the same thing as y. So all I'm doing on these problems is replacing the y with f of x. So on the first one, I would just have f of x equals 7x minus 4. Replace the y with f of x. F of x equals the square root of 8x minus 3. And the last one, replace y with f of x. F of x equals 2x squared plus 3x minus 9. So that's all you have to do on number one. That easy. All right, so continuing down here on the next problem here, it says consider the following functions. So here now we're going to evaluate the functions. So notice how we have three different functions here. We have f of x, we have a g of x, and we have h of x. So notice how a and b here go with f. So the first one just says find f of 3. So on your test, what I want to see is the notation here and you plugging in the number into the equation. So I would need to see your work on the test. So f of 3 equals, now the rest of it can be done on the calculator. So 5 times 3 minus 7 equals 8, and that's it. So I'd want to at least see this first step. So just telling me the answer, not going to get you full credit. Okay? So like on the next one, f of x, whoops, I don't want f of x, I'm replacing the x with negative 6. So I'm trying to find f of negative 6. So I'm going 5 times negative 6 minus 7. So f of negative 6 equals, calculator time, 5 times negative 6 minus 7 equals negative 37. All right, so next one goes with g of x. So actually the next two problems, C and D, deal with this absolute value function. We know that absolute value is distance from 0. Okay, so to do the first one, we're trying to find g of 5. So we're doing 2 times the absolute value, 5 minus 1. So using our calculator, remember that absolute value can be found by going math, using the right arrow, and number 1 on our calculator. So to enter this in on my screen, I put the 2 on the outside first. Then I hit the math key. I slide over 1, so I get ABS, absolute value, 5 minus 1. Enter that in, and I get g of 5 to equal 8. All right, so now I do the second one. G of negative 5. So the sign changes here a little bit. 2 times negative 5 minus 1, absolute value. So g of negative 5 equals, calculator time again, 2. Again, to get that absolute value, math, right arrow, number 1. So I'm going negative 5 minus 1. Move my cursor outside, and I get g of negative 5 to be positive 12. All right, the third function given to you is h of x equals the square root of 5x minus 1. So I'm asking to find h of 10. So again, I'm replacing the x with 10. So I get h of 10 equals, so I'm going square root 5 times 10, subtract 1, go ahead and hit enter, and lo and behold, we get 7. Look at doing the second one. H of x equals the square root 5 times 13 minus 1. Whoops, I didn't mean to write h of x, Mr. Barks. That's like twice you've done that. I need to replace that value not with x, but 13. So h of 13 equals, so I go square root 5 times 13 minus 1, all under the square root, and I get, oh, look at that, 8. Nice. So that takes care of those. Now, the last two problems are the little bit more challenging. This is where we're replacing not the x value, but we're replacing the function with a value. So, like for instance, this one says f of x equals 23. So what I'm doing is I'm going up here to the equation and I'm putting the number 23 right there. So I'm starting off by saying 23 equals 5x minus 7. So then I am just solving that equation. Inverse operations say add 7 first. So I get 30 equals 5x. Divide both sides by 5. And x equals 6. Now, one of the cool things I could actually do is plug 6 into the function itself. Go 5 times 6 is 30, minus 7 is 23. I know my answer is correct that way. All right, so last one here says find x if h of x equals 13. So I'm going to put 13 right in that spot right there. So I'm going to say 13 equals the square root of 5x minus 1. So inverse operations, square both sides. So 169 equals 5x minus 1. Add 1 to both sides. So 170 equals 5x. Divide by 5, and x equals 34. So one of the things I could do is I could check. I could say, all right, whoops, that was weird. The square root of my 5 times my answer, 34, minus 1. When I hit enter here, I better get my original function, 13. All right, so that takes care of already the first page of the notes. Look at how quickly we are going. All right, so the rest of the notes is actually using inverse operations to solve all the different types of equations. So this first page has square root equations or square equations. Remember, square root equations are either going to have 0 or 1 answers. Square root could have 0, 1, or 2 answers. Most of the time it has 2. Most times square root has 1, but they all can have 0 from time to time. All right, so let's start plugging away. Inverse operations. First one, the square root's already by itself, so I square both sides. So now I get 3x plus 12 because the square and square root cross out. 6 squared is 36. Now start doing my inverse operations. I minus 12 from both sides. So I get 3x equals 24. Divide by 3, and x equals 8. Now one of the things I like to do is check my answer. So I go square root. 3 times 8 plus 12. So now when I hit enter here, this better equal 6. Ding, 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 ding. Just got that one right. Sweet. Let's take a look at the next one. the square root of x plus 5 minus 7 equals 2. So I have this minus 7 I have to get rid of. So to move it to the other side, I do the inverse operation of adding 7 to both sides. So now I have the square root of x plus 5 equals 9. So to undo a square, undo a square root, I square. Cross out, x plus 5 equals 81. Subtract now 5, x equals 76. So now I'm going to check that answer. So I go square root 76 plus 5. Move the cursor outside the square root because then I subtract 7. When I hit enter, that better equal 2. Just like that, I'm 2 for 2. Mr. Bartz is rocking and a rolling here. All right, next one. We have 3 square root of x plus 4 minus 8 equals 4. So the first thing I have to do is add 8 to both sides. So I have 3 square root x plus 4 equals 12. Now I have this 3 on the outside, so I got to divide both sides by 3. Square root of x plus 4 equals 4. To undo a square root, I square both sides. So I have x plus 4. 4 squared is 16. One last step is to subtract 4 from both sides, and I get x to equal 12. So let's check just to make sure it works. 3 square root of 12 plus 4. Move it outside, subtract 8. So when I hit enter here, I better get 4. And lo and behold, I do. All right, let's take a look at the very last one. 5x minus 4 inside equals 6. So the first thing I have to do is square both sides. So square and square root cancel. So I'm left with 5x minus 4 equals 36. Now I need to get rid of the minus 4. So I add 4 to both sides. So 5x crosses out equals 40. Divide both sides by 5. X equals 8. So again, I'm going to do a last check. Square root, whoops. So square root of 5 times 8 minus 4 equals 6. And it does equal 6. So just like that, I got all those problems right. So the nice thing here, at least on my square root problems, they all had one solution. I didn't get any no solutions because it never equaled a negative number. All right, so now let's go to the square problems. So now on these problems, many times, maybe not all, but many times I'm going to more than likely get 2 solutions. Maybe I'll get 1, maybe I'll get 0. But when we solve these and we undo a square, don't forget the plus minus. So like on this very first one, I square root right away because I got the x squared all by itself. Don't forget that plus minus. So I have the equation x minus 6 equals plus or minus the square root of 49 is 7. So now what this means is I have 2 equations to write. I have x minus 6 equals 7 or x minus 6 equals negative 7. So here I'm going to add 6 to both sides. So I get x equals 13. Or when I add 6 to both sides here, I get x equals negative 1. Now I can always check. So parentheses, 13 minus 6, close parentheses squared. When I hit enter, this better equal 49. And it does. Check the other one, negative 1 minus 6 quantity squared. Hit enter, and I also get 49. All right, that takes care of that one. Let's move to the next one here. So, first thing I actually have to do is take care of this minus 4. So I'm going to add 4 to both sides. So I have x plus 1 quantity squared equals 32. Or sorry, 36. 32 plus 4 is 36. All right, undo a square by square rooting. So now I just have x plus 1, those cross out, equals plus or minus 6. So now that means I have two equations to write. X plus 1 equals 6, or x minus 1 equals negative 6. So now I subtract 1, x equals 5, or add 1, and x equals negative 5. Whoops, I apologize. Mr. Bartz. Oh my goodness. I see a mistake I made. Because Mr. Bartz copied something down wrong here. He's going to say that just looked weird to me. That should have been x plus 1 there. So when I subtract 1, I'm glad I caught that. X equals negative 7. My guess is I would have caught that mistake when I plugged it in. So let's plug it in. So, parentheses, 5 plus 1, quantity squared, minus 4. Whoops, it didn't take my subtract 4. When I hit enter here, this should equal 32, and it does. Plug in my other answer, negative 7 plus 1, quantity squared, minus 4, better equal, whoa. Oh, again, it didn't take my minus sign. That is just frustrating sometimes for me as a teacher. When using this calculator on the computer, it sometimes doesn't take my keystrokes. I just got to make sure I typed it in correctly, and I get 32. So I know my answers are correct in this case. Whew! My goodness, we almost made some mistakes there, but luckily checking and just kind of watching through it, we caught the mistakes before we went too far. All right, on the next one, first thing we want to do is subtract 9 from both sides. So I get x minus 5 quantity squared equals negative 3. All right, this better start to kind of go dee-dee-doo-doo. Wait a second. Can't equal a square, cannot equal a negative number. So right here you could say no solution. An x squared cannot equal a negative number. So if you can see that right away, that's awesome. Otherwise, if you actually try to solve this and you start plugging it back in, you're going to see that, hey, you know what? The answers actually don't work. All right, let's do the last one here. This one has all the big numbers. All right, so the first thing, though, it looks really big. I think we can handle it. First thing I'm going to do is subtract 19 from both sides. So when I do, I have 6. X minus 3 squared equals 150. Divide by 6. X minus 3 quantity squared equals 25. Square root, plus minus. So it crosses out on this side, so I'm left with x minus 3 equals plus or minus 5. So again, this tells me two equations. So I'm going to just kind of move this up here a little bit. So one of the equations is x minus 3 equals 5, or x minus 3 equals negative 5. So on this one, I'm going to add 3 to both sides. So I get x equals 8. Or on this one, when I add 3 to both sides, I get x equals negative 2. So again, I like to check 6 parentheses. One of my answers was 8 minus 3, close parentheses, squared. And then I have to add 19. So when I hit enter, this better equal 169, and it does. Check the other one, 6, negative 2, minus 3, close parentheses, quantity, squared, plus 19 equals 169. I know all my answers on the second page of the review are correct. That's what I love about these. We should know if our answers work or not. All right, let's go to our very last page here. So it says solve the following absolute value equations. So again, with absolute value, just like squares, we know that we're going to have either 0, 1, or 2 solutions. Most of the time, we're going to have 2, okay? But know that 0 and 1 could happen. So the idea is get absolute value by itself. So what this is saying is x plus 4 is 8 units away from 0 on the number line. So that means x plus 4 could be located at 8, or x plus 4 could be located at negative 8 on the number line. So now I just have to solve these two equations. So I subtract 4 from both sides. So x could equal 4. Or when I subtract 4 here, I get x equals negative 12. So again, I can check these answers. So remember, absolute value is math, right arrow, number 1. So I'm taking the absolute value. My first answer is 4 plus 4. Go ahead and hit enter. It does equal 8. Math, right arrow, absolute value. My other answer was negative 8 plus 4. Hit enter. Maybe if I'll take it there. And that also equals 4. I know my answers are right. Sweet. All right, let's take a look at the second one here. All right, the second one here, I got some math to take care of on the outside. So the first thing I have to do is I have to subtract 1. So I have 2, absolute value, x minus 3 equals 4. Then I got to divide by 2. So the absolute value of x minus 3 equals 2. So what it's saying is x minus 3 is 2 units away from 0. So that means x minus 3 must be at 2, or x minus 3 must be located at negative 2. So solve each of these equations. So I get x equals 5, or I get x equals 1. So again, I want to check my answers. So this one is a little more work to type in. So I go to math, select my absolute value. My first number was 5, 5 minus 3. So I got to use my right arrow to kind of move outside of it. And I have to add 1. And sure enough, it equaled 5, as it says right there. So I do the second one, 2, math, absolute value. Now I plug in the second answer, 1 minus 3, move the arrow outside, and I add 1, and I also get 5. Just like that, 2 for 2. 3 more to go. All right, the next one. I'm going to, first of all, subtract 9. So I have the absolute value of 3x minus 6 equals 18. So I have the absolute value by itself. So what this means is 3x minus 6 is 18 units away from 0. So either 3x minus 6 is located at 18, or 3x minus 6 is located at negative 18. So solve each of these. So I'm going to add 6 to both sides here. So I get 3x equals 24. Divide both sides by 3. X equals 8. Solve this one. Add 6. So 3x equals negative 12. Divide by 3. X equals negative 4. Okay. So let's check those. So I start with the absolute value. So it says 3 times one of my answers, so 8 minus 6. Go outside, add 9 to it. So when I hit enter here, I better get 27. And I do. Go math, number, absolute value, 3 times my other answer, negative 4. whoops, I want to still stay inside there because I have to still minus 6, then add 9. This also better equal 27. And I have both my answers. All right, last two problems. All right, so the next one here. Absolute value x minus 5, then plus 4 equals 3. So I got to subtract 4 from both sides. So absolute value of x minus 5 equals -1. Ooh, absolute value can't equal negative number. So here's our no solution or zero solutions. No solution, absolute value cannot equal a negative number. Wow, that one went quick. All right, last one. Same process, just a little more math. So first thing I need to do is subtract 8 from both sides. So I have 2, absolute value of x minus 7 equals 6. So now divide both sides by 2. Absolute value of x minus 7 equals 3. So now I have two equations. X minus 7 equals 3, or x minus 7 equals -3. Solve both of these. So add 7 to both sides, so x equals 10. Or add 7 to both sides, x equals 4. Let's check both of those. 2, math, number. First one I'm plugging in is 10 minus 7. Move it outside, add 8. So when I hit enter here, it better equal 14. And it does. Do the second one. Plug in 4, so I'm going 4 minus 7. Move it on the outside, plus 8. This better also equal, whoops, it forgot the plus 8 there. So hang on here just a second because that did a little slash. That always drives me crazy. I'm just going to go second enter and go plus 8. So that was my typo. And it does equal 14. So again, if it doesn't, I kind of look at, did I enter it in the calculator right? So both answers are correct. All right, so that is your review. Good luck on your test. It should be open and ready to do. We'll see you tomorrow.